Okay, hello everyone. Today I'm having a new lecture for class 12th. The topic is the Gaussian theorem. It is chapter number 2 from your textbook. We are starting with the Gaussian theorem. Before starting the Gaussian theorem, some important terms which are important. Let us see them one by one. The first is the area vector. Now, area vector is nothing but a plane area can be regarded as a area vector if it possesses both magnitude and direction, and its direction is outward drawn normal to the area. Now let us understand this. He is saying you area vector is a vector which is having direction as well as magnitude. So suppose this is the plane, the direction is outward toward the normal, where n is the unit vector. So mathematically we can write area vector A equals to unit vector n into A, where n is the magnitude and this shows you the n cap is the unit vector. So this is area vector. Now after this, the next is the solid angle and the plane angle. Now plane angle is the angle which an arc of a circle forms with a center. So it is very simple. The angle which the arc of a circle makes with the center is called your angle, is called plane angle, and its unit is radian. It is measured in radian. We can measure this in radian. After this, we are having a solid angle. Solid angle is the angle which the solid sphere makes with the center of the sphere. So solid angle is the angle which the solid which, or we can say which the area of a small area makes with the center. So it's called a solid angle. Its unit is star radian and it is denoted by the symbol omega. It is denoted by the symbol omega and measured in star radian. Now suppose dw is the small solid angle. It is directly proportional to the area. It is directly proportional to the area. Suppose this is the area. If we increase the area, obviously the angle omega will increase. So we can say it is directly proportional to this. And to remove this proportionality sign, what we have to do, we have to put a constant, and constant we are putting here is 1 upon r square, where r is the radius. So we can say d omega equals to r square, dA upon r square. So this ratio will remain constant. So this is how we are defining this. Now unit is star radian. As you know, the unit is star radian, and omega equals to a upon r square, means area upon r square. So this we have found it out now. So omega equals to a upon r square. So the value of a when it's rotate, the surface area of the sphere will be 4 pi r square. So we have put it the value 4 pi r square here. So r square get cancelled. So it means the maximum angle which maximum solid angle is equals to 4 pi. So this is the fixed value for the max, or we can say the maximum value. Now the flux of a vector field. Now flux of a vector field are the field line passing through the imaginary surface in the field. Suppose you are having the electric field, and if we imagine a surface over there, and the electric lines passing through that area is called the electric flux, or we can say the field vector. Suppose this is the electric field and this is the imaginary area. We have created the imaginary area, and these are the line passing. So if the field is dense. If the density of this line is more, obviously we can say that this flux means phi is directly proportional to E, means it is directly proportional to the intensity of these lines. K, if the density is, if the lines are densest, so more line can pass through this area, so it is directly proportional to E. And also it is directly proportional to the area. Area is more, so when the area is more, obviously the phi E will be more. So combining these two equations, we get phi E proportional to Es, or we can say Es cos theta, where cos theta is the angle which the plane makes with the electric lines of forces. So we can say Es cos theta. And for the maximum value of phi E, that means theta should be 0. So that means we have to place this perpendicular to the electric lines of forces. So we can say K phi E equals to Es. So this is the maximum value. Now after this, the electric flux density. Electric flux density is nothing but it is the ratio of electric flux upon area. It is the ratio of electric flux upon area. So simply what we have to do, we have to find out the flux, and divided by area you get the flux density. So flux density, this is flux density phi E upon A. So but phi E we know it is equals to Es. In place of S we are putting A here, so A get cancelled, so flux density equals to E. Talking about the unit of the electric flux density is same as the electric field, because A get cancelled, so the unit will be same. So don't worry about the unit will be same. Whatever is the unit of intensity is the unit of electric flux density. After this, let us talk about the unit and dimension of electric flux. So flux and let us find out the dimension of electric flux. So we know that phi E equals to EA, where E is the electric field intensity and A is the area, and E equals to F upon Q. So we have put it the value of F upon Q. F upon Q is put it here. So FQA, the dimension for F is MLT minus 1. Dimension for A is L2. Dimension Q equals to IT, we know. So I is the current and T is the time. So dimension for I is ampere. Dimension for T is dimension for T, small t, is T only. So T is the time, so dimension is T. So by solving this, we are getting MLT minus 2 L 2 A minus 1. So this is the dimension of the electric flux. In MKS system, the unit of electric flux is kg meter cube per second square, and in SI system you can find out the unit from here. So it will be Newton meter square per coulomb square. So Newton meter square per coulomb square is the dimension, is the unit, is the SI unit for the electric flux. Now solid angle, I think it is clear to you. Solid angle is the angle which the area of the sphere forms with the center. Maximum value for that is omega. Maximum value is 4 pi and it is denoted by omega. Now let us start with the Gauss theorem. It is very important. Let us see the statement first. The statement says us that according to the Gauss theorem, the electric flux through any closed Gaussian surface is equals to 1 upon epsilon 0, the 0 times the charge through the Gaussian surface. It says you that K electric flux is 1 upon epsilon time of the charge. This is the statement for the Gaussian theorem. We are having a proof also, but proof we will see in the next video. Thank you very much. Revise it nicely and wait for the second video.